Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Leslie Tolbert, Regents Professor Emerita in Neuroscience at the University of Arizona, and this is Arizona Science. Our guest today is Joe Giacalone, professor in the Department of Planetary Sciences at the University of Arizona. Joe's one of the lead scientists on the Integrated Science Investigation of the Sun instrument. Thanks for joining us today, Joe.
Well, thank you very much. It's a pleasure to be here.
So what drew your interest to the sun?
Well, I started as a physicist, and I was interested in astronomy and astrophysics. And the sun, and particularly the physics related to the sun, we have spacecraft that measure these things in situ. And I kind of like that very hands-on, we have the data at hand aspect of this problem.
You send spacecraft toward the sun to get closer to collect information about this radiation from the sun. Tell us about what you're learning.
There's many puzzles about the sun. One of the key puzzles is the corona happens to be extremely hot. It's well over 1 million degrees of Kelvin, so extremely, extremely hot. How the corona gets that hot is not well known. The photosphere, which I mentioned before, is far cooler. It's maybe only 5,000 to 6,000 degrees Kelvin, which, fine, that's still very hot, but it's a factor of 1,000 or several hundred lower than the temperature of the corona.
So it would be as though the air around the Earth, the atmosphere around the Earth, were much hotter than the Earth itself.
Yes.
So how does this happen?
We've theorized that it probably is related to the conversion of strong magnetic field into flows. Magnetic fields, especially with sunspots and other active regions on the sun, but even when there are no sunspots and active regions, there are strong magnetic fields on the sun, and they're always moving around, wiggling around, bubbling up from below. These magnetic fields can heat the gas. And that's the theory, but there's various problems with the theory, and we need more observations to determine this.
What does this magnetic field mean for our day-to-day lives?
On the one hand, there are, and perhaps the biggest noticeable effect is on industry. Even during periods of very strong solar activity, Earth's atmosphere actually expands a little bit, and that leads to a significant drag on satellites. And in fact, during periods of lots of solar activity, a period known as solar maximum, the increased atmosphere expanding actually does lead to the degradation of orbits, and even many that get swept out and crash and burn through the atmosphere. So if you constructed that satellite, you don't want to lose it because you didn't account for space weather effects. But day-to-day life, there can be, swiping a credit card at a gas machine maybe not work, and it could be attributed to a solar event. But perhaps another one is the aurora can be seen very, very low latitudes. And during when a large, what's known as a geomagnetic storm, when a coronal mass ejection strikes Earth's magnetic field, the Earth's magnetosphere, the gas that's sort of contained within Earth's magnetic field, far from the atmosphere, gets filled up, and the magnetic field sort of retracts a bit like a rubber band. And when that happens, a lot of plasma is injected into primarily the polar regions. And when that plasma gets injected, it creates a light show. During really big events, that can extend to really low latitudes. It's not just confined to the what's known as the auroral oval at high latitudes. And in fact, like I was mentioning, in 2000, there was one here in Tucson. I have a picture of it. I have an old photo of the aurora that took place here in Tucson. It does happen. It's very rare to get such low latitudes. It takes a particularly large solar event for that to happen.
Well, this is absolutely fascinating, and I dare say most of us humans on Earth had no idea that the sun was having such sort of direct impacts on our lives. Thanks very much for talking with us about this.
Yeah, my pleasure.
Dr. Joe Giacalone is a leading expert on space plasma physics and cosmic rays. You can listen to this and all Arizona Science conversations at azpm.org/Arizona Science. I'm Leslie Tolbert.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.